Hello class, my name is Duncan Hazel, and for my final lab I did the physics of a three-point basketball shot. I asked myself what forces and physics principles are being used when attempting a three-point bank shot, and would a computer simulation be able to make a shot dealing only with forces. So here's me taking a shot and using the tracker video to make the three-point bank shot. I made a Python simulation just to see what would happen and try to emulate what I did. I started with two balls. I made a ball for the computers of the actual shot, and then a ball of the simulation. And I also made a graph just to compare like energies, just to see what was interesting about that. The mass of a basketball is about 0.6236 kilograms. Originally, the ball started at the position of -0.015 according to the axis. The axis was like, I tried to make it as close to the ball as possible where it started. And then, of course, both balls start in the same spot. I calculated the initial velocity by taking the first and second point, finding the distance, and then dividing by the total time, which ended up being 4.24 in the x direction and 6.1 in the y. Then I created an Excel document with the x and y values over here, and I imported it into my program. So after that, g is -9.8 in the y direction, and then I use this to calculate potential energy and kinetic energy, and so then force of gravity is the ball times mass times the gravity, and then F net is just the only force acting on the ball is gravity. I use this as a recursive to find the velocity at each point, and then the position I use the same way. I create a trail to append the info in the ball movement, and then I find out the kinetic and initial and potential energies of the ball for information. And then I do the same thing. This is the same thing here. This is just for the simulation, and I'll go ahead and run it for you. So as you can see, the blue ball is the blue ball is the actual shot, and the orange ball is the simulation. So that means obviously the blue ball was a perfect shot, and that's the only it has to be like at least pretty close to that, and the orange ball is very far away, so obviously there are other forces affecting that, which I count for air resistance and wind. So that's why the computer, obviously, if they took a shot and made the calculations, they'd airball. So also I thought it was interesting that the final energy of the bank shot, like the calculated is, it's not complete, it's not zero. Like it makes sense that it wouldn't be zero. It's actually lost some energy because of air resistance, so it's actually a negative number, a very slight negative number, but nonetheless it's negative. And then here's a graph of the positions. Obviously the green one actually went much farther because the air resistance, we didn't take into account air resistance for this, and we just took into account the position of the ball. So the main result is the forces and physics principles used in the experiment are momentum, principle, gravitational forces, and air resistance. A computer would airball a three-point shot if it was given the chance to shoot. Momentum, the momentum doesn't change throughout the ball, mostly because, so with the collision between the ball and the backboard, the backboard only slightly moves with very little velocity, so it's essentially zero, and it only creates a slight change, so that the final, it's just mv of the little ball of the basketball. The only forces in this problem, besides the initial force of the hand, which we don't take into account because the ball's already left my hand, is force of gravity, which is just mass times gravity, and then we have air resistance, which we did not calculate, but we know that it affected the final result. So that's my video, and thanks for watching.